Today we're looking at finding the area under a graph. This has got lots of applications which we'll look at later. For the moment, we want to be able to find this area here. Now normally, with areas, we will chop the area into shapes that we understand, like rectangles, triangles and so on. Find the area of each and add them together. Integration has a special technique of doing this. If we make lots of little rectangles and measure the area of each and add them together, we can get the area under the curve. This rectangle here, if we make the bottom of the rectangle very small, and we're going to call it dx, it's a very small change in x, the height at any given point would be given by the y-coordinate on this curve. In this case, 4x minus 3x squared. So that means for the area of that rectangle, the area of a rectangle is length times breadth, we would have the 4x minus 3x squared times dx. Now we need to imagine there's lots of little rectangles. And what the integration function does is it sums together all of these areas between the limits that we tell it. So it takes every rectangle between our limits, in this case b and a. Now you don't need to memorise this, you're not going to be asked for this in exam, it's just to give you some background. Now we're asked to find the area underneath the curve between the values of 4 and 5. So we're just going to go right ahead and integrate x squared minus 4x dx between the limits of 5 and 4. So we'll integrate as normal, x cubed over 3 minus 4x squared over 2. We can cancel there. At this point I have square brackets and I still have my limits in place. Now it's time to substitute. 5 cubed over 3 minus 2 times 5 squared. All of that take away 4 cubed over 3 minus 2 times 4 squared. Remember to keep those round brackets in so that we don't get into problems with our negatives. Now at this point I'm going to evaluate slightly and then remove the brackets. 5 cubed, 125. So 125 thirds, take away 2 lots of 25, which is 50. And all of that subtracting 4 cubed is 64, so 64 thirds minus 2 times 16 is 32. Now, I've got 125 thirds minus 50. I'm taking away everything in this bracket, so minus 64 thirds. I'm taking away negative 32, so it's plus 32. I'm going to deal with the thirds first, so 125 of them, take away 64 of them, will leave me 62 of them, and I've got negative 50 plus 32, which will give me minus 18. I'm going to change that into thirds as well, so 62 thirds, take away 54 thirds, will leave me 8 thirds. Because it's an area, I'm going to say units squared. I don't know what the units are because this question isn't given in context. So you can see for finding the area under the curve, it's just a definite integral, and the limits are the limits on the graph. Now in this particular example we were given the limits. There will be times where we're not and we'll need to calculate those. There are 2 more examples in your notebook, but they consider areas under the x-axis, which gives us a particular problem that I want to discuss with you when we're in class.